Are there any questions? All right. We last left off looking at the two free ends and the harmonics. So we have the tube here predicting what that frequency is. And I don't think we ever got to the point where we could go, yeah, we nailed that. Other than, I think I might have made a statement. But refresh your memory, so for the two free ends. And a free end, node or anti-node.
What was the question?
A free end, when I draw the harmonic, is it a node or anti-node?
Anti?
Yes. That's where you get the largest vibrations. So the first harmonic, so it'll look more curved than I've drawn that. So in terms of sound, that's where the air has the biggest fluctuation in sound, and so it would sound the loudest. In theory, if I'm on the first harmonic, it should be completely silent, smack dab in the middle, but any device I put on this in order to measure that would disrupt it, and therefore can't really trust that as a test. If that is the length L, how many wavelengths is this? So the wavelength is equal to 2L. We established that the length was, I think, 86 centimeters. Okay. And so therefore the wavelength that is produced would be twice that, or 1.72 meters. Yeah, that's right. I know speed is frequency times the wavelength. And so the speed of sound, 340 meters per second, is equal to the frequency times 1.72 meters. I think we did all of this last time. And we got as far, it'll be easier for us to see some of its notes. So third harmonic, we got down to the frequency. All right, so this was 197.67 hertz. That was for the first harmonic. Second harmonic looks like this, and that frequency was
395.35.
395.35,
Yeah.
and then the third harmonic
It was 596.49.
Okay. Now, that's supposed to be 395.35 hertz. There we go. And if I played it on here, 395.35. That one. And in my mind, they sound similar, but I don't have great hearing. Earlier today, I was doing this, and the student claimed that you could hear the difference between 440 and 439 hertz. So I'm trusting people with different abilities. So So the way that we can actually tell is to see if we get a beat frequency. So as I'm spinning this around, when I play that at the same time, are we gonna hear that extra trill? Now, if it's really close, it'll be like, whoa, whoa, whoa. I'm probably not gonna be that close. It's probably gonna be a small little trill like in there, but let's find out what happens. Like there's a little extra of a trill in there. Ashlyn, I'm not quite sure which way you're going on that one. You're not hearing it?
It's not the same.
Sounds the same to you?
No, it doesn't.
What's wrong with your hearing?
I don't know.
Everyone else heard it, right?
No, I heard it. It just doesn't sound the same.
It just
Doesn't sound the same.
it does not sound the same. Okay. Oh, you're talking the sound from this and the sound from that does not sound the same.
Yeah.
Okay, I accept that.
Okay.
But in the sound, did you hear, I heard just a little bit of an extra wobble in there. And if you've forgotten sort of, this is what it would sound like. See, that's 395.35 and 395. That's when they are roughly a third of a hertz off, so that beat frequency should have been about 3 hertz, or sorry, the beat frequency would be about a third of a hertz, which would put the period about 3 seconds. However, if I'm off by, let's say 10, so 395 and 385. It's a lovely sound. Now, I think we're a little bit further off than that, but not so far off. If I go off by 20, let's see what that sounds like. Let's see, 375 or 3000. So let's go back to our 395, 35. By itself, definitely hears the difference. I heard it, and the international fans will hear it. So if you're not hearing it, let's try the next one. Let's see how close we get to it. 596. .49. Now, there are differences between plastic and speaker, but hopefully you heard a little bit of a trill there, probably a little bit farther off than we were before, but because it's such a pleasant sound, let's crank that up just a little bit. Without that, that pretty much sounds the same as it did before. So I didn't hear the trill that time, but I did hear something on the first one. Questions? Because we're about to do one fixed, one free. Fixed in, node or anti-node? In units would be really cool right now. Okay, in rounds a little bit there. Yes, it is indeed a node. One fixed, one free. So it means I'm gonna have, whatever my pattern I come up with here, I'm gonna have a node at one end and an anti-node at the other. That is the simplest pattern. This is the first harmonic. And the big question is, how many waves is this? Remember that a full wave, that's a full wave, that's a full wave.
Third.
Not a third.
Fourth.
Yeah, it's a fourth of a wave. So L is equal to a quarter of a wave. Therefore, the wavelength is 4 times whatever that length right there is. It's as if I've got this, it's broken up into 4 equal pieces. And we're just looking at this piece right there. From node to anti-node, it's a quarter of a wave. Now, we add a half a wave every single time. That is a pattern that does hold true regardless of how many fixed or free ends there are. So if we add a half a wave, I still have to have a node at one end and an anti-node at the other end. And I'm going to attempt to draw this correctly. Better than what my first attempt was going to look like. How many waves is this? You said 3? Not 3, if you're stopping there. So it's as if we've got our full wave right here, and we just took off that end.
One and a half.
Sorry, you're speaking so softly.
One and a half.
Not 1.5 waves, 1.5 loops. How many waves would that be?
3/4.
Yeah, 3/4. That's when you said 3, I was waiting for the quarter to show up. L is equal to 3/4 of a wave. Because you add a half every time. If I have a quarter in my pocket and then someone gives me a half a dollar, I got 3/4 worth. Now, just to mix things up, just to make it seem like they have no sense of order right here, this is actually not the second harmonic. This is the third harmonic. Now for the videos that I've done, early on I was calling it the second harmonic because it's the second one. Really, it is the third harmonic. I think I've corrected that on any of the videos that I have, but it's possible there's one out there where I call it the second harmonic improperly. It's that number right there. First harmonic, third harmonic. The next one, going by the pattern.
Fourth harmonic?
Not the fourth. Yep, the fifth. If we add a half every single time, that's 2/4, so we're gonna go up by 2 every time. So the next one is the fifth harmonic. And so we have our full wave right there, plus another quarter, so we got 1 1/4 waves. L is equal to 5/4 of a wave, or for the decimal fans out there, 1.25 waves, or for the mixed number fans, 1 1/4 waves. So the wavelength is going to be 4/5 of the length. Here, the wavelength would be 4/3 of the length. Now the big question is, can we actually demonstrate this? And you're in luck, we can. However, I do need water. This looks pretty empty right here. And I'm hoping a little bit of water in that. Maybe the leaks have been dealt with. Right, it's going to require. Now, it is possible, as I adjust this, that you're going to hear metal scraping on metal. It is what I would consider an incredibly unpleasant sound. I apologize. Just do it slowly. Come on. Trying to avoid that. Let me go grab some water. Let's see, that's being used for something. Yeah. I'll be back. All right, I'm gonna pause this. If I forget to turn this back on, if someone would remind me, that would be much appreciated. So I can adjust the water level in this by just moving this up and down. Assuming there's no clog in there, which I hope there's not. So you notice the water level is rising. It's going to rise up until the water level here and here are the same. Ooh, what I forgot to bring were tuning forks. Is there one in here already? Oh, here's one. Okay. Can all of you hear that? All right. This is 512 hertz. I know that because it says 512 right there, and I've actually tested these with some of the LabQuest equipment, and it actually does come out to be what it claims. So the frequency, 512 hertz. I know the speed of sound is about 340 meters per second here in this temperature. And so that's the speed, and I know the speed is the frequency times the wavelength. So therefore 340, the speed, should be equal to 512 times the wavelength. If someone would be kind enough to do the fancy math and tell me what the wavelength of sound is that is being produced. .66 units.
Pass.
Is it pass?
Yeah.
All right.
Meters.
Yes. There we go. As a team, we got it. Now, 0.66 meters. So the first harmonic should happen when the length of the, what will be the air tube, is a quarter of that. So the first harmonic, so let's call it L1, is going to be a quarter of the wavelength, so 1/4 of 0.66. 0.1. Repeating, what?
165.
165 meters. Now, thus we bring the water tube in. I'm going to take the tuning fork, get it going. Oh, and there's one right there also, but I guess we just did the calculations for this one. place it over that, and the sound is basically vibrating back and forth. The two bars here are vibrating very, very quietly, and you can sort of test that just by, well, part of that was my shaking hand. So this is vibrating back and forth. Matter of fact, it's vibrating back and forth 512 times every second. The sound is going to go down, it's going to hit the fixed surface down here, the water, and then bounce back. And so when we get to the harmonic, ideally, it should be silent down at the bottom, not that we can tell, and it should be the loudest here at the top. So that's what we will hear. So it's going to be loudest when we hit there. Now we do have measuring tape on the side here. And for some reason, and I thought I had an explanation at one point, but I'm not 100% sure of that, 0 starts 2 centimeters below the top. So whatever we read on here, we just need to add 2 centimeters to it. Now the first one should occur at 16.5 centimeters, which on here would be 14.5, which is right there. So I need to raise the water. All right, so we are above. Now, whenever you're kicking these things off, even though it makes a much louder sound, if you bang it against something hard, please don't. This is one of the newer ones. Actually, these are both some of the newer ones. Some of the older ones you can see, well, even on this one, you can see scratches and so forth in it as it slowly gets damaged from people just banging it on things they shouldn't. The ends are vibrating the most, so I really want that over the entrance there. So get a little bit closer. So now it's going down, bouncing back up. Now let's see if we can get it to be a little bit louder.